Okay, we're going to work with factored form of quadratics. So we've been given another factored form. And if you recall, the general equation for factored form looks like this. X minus R. I think you guys use S and T instead,
Yeah.
or S and T. It's not very clear. Just in those placeholders. Whatever variable you want, it's not too important. Let's remove that. It may not be that clear. But we've been given a specific quadratic in its factored form almost. What's key about factored form is recognizing that in the general form, the coefficients in front of the variables are 1. So in other words, we need to make sure that the coefficients in front of our factored form are 1 before we can start to apply any of our visual cues to tell us about x-intercepts and y-intercepts. Now technically I can find an x-intercept without doing this, but what's also missing here is a proper a value. There is an a value, technically it's 1, but we say this is the true a value when the coefficients in front of the variables are 1. And then we have a true a value. Because these coefficients are not 1, this is not our true a value. So in other words, what we have to do is we need to remove the numbers in front of those coefficients. So we're going to do this one step at a time. So the very first bracket here, I have 3x and 9. I'm literally just going to divide by the coefficient in front of that variable. So in other words, I'm going to common factor out 3. So I have 3. And then that leaves us with x minus 3. That's not so bad. It's an easy to understand one. Then we're going to take a look at the second one. The second one is not as nice to work at. This is not only a large value, but it's also negative. So I'm going to factor out negative 18. And I'm going to do it from both of these terms. So negative 18 comes outside. So think of it like we're multiplying by negative 18. And then what's left inside is 6 divided by negative 18 is going to give me negative 1 over 3. And this will give me plus x. Okay? So the second half of this didn't come out as cleanly as the first. In order to get a true a value, I have to take any of these values here that are being multiplied, and I got to put them together. So 3 times 18, I actually don't know this off the top of my head. Let's see, what's that going to be? 4, 2, I think it's 54, but maybe you double check that.
Yeah, negative 54.
Awesome. And then I'm going to rearrange that second bracket there. Since I've already dealt with 1, 2, 3 of the terms that we were multiplying, I'm just going to rearrange it so the x value is in front. So we have x minus 1/3. Amazing. So what we now have is a much truer or closer representation of factor form to our general equation. Here is our a value. We have an x minus r, where their coefficients are both 1. That works. And we have an x minus s, where the coefficients are both 1. Boof, that works. Excellent. So if they're going to ask us questions about a happens to be negative 54. Some of the things they might ask us is, does this open up or down? In other words, does the parabola look like this, or is it an upside down U? Because a is negative, we have it opening downwards. That tells us that already. Also, a is greater than 1, which means we are narrower, or commonly known as stretched. Yeah, vertical stretch. Compressions would be if a is less than 1. So that's another thing we can talk about now that we have a proper a. I can also visually tell you my roots, my x-intercepts. So the x-intercepts are literally the shouldn't say absolute value, the opposite value of the number that is taking up the space of r and s. So because this is negative 3, one of my x-intercepts is 3, and the other one is positive 1/3. Now you may look at that and go, well, how would we know that? And what we can do is we can do a little side of the envelope algebra. So I'm going to highlight what I'm going to work with here. We're going to work with these two. We're going to set each of those brackets equal to 0. So do it on red in the side. X minus 3 is equal to 0. Okay? And when we solve for that, x is equal to 3. Yeah, that's exactly what we checked out. And then x minus 1/3 is equal to 0. Same concept. X is equal to positive 1/3. Yeah, that checks out. The reason this is true, I've never shown this part algebraically, I'm going to put it down here, is to be an x-intercept, your y-coordinate needs to be 0. So in other words, this has to say 0 is equal to negative 54 x minus 3, x minus a third. Okay, this concept in mathematics is extremely powerful, what we've just set up. You're going to use it again and again and again further on. We've set a function, for your function notation, or an equation equal to 0. And what's nice is on the other side of the equation, we have terms that are multiplied by each other. The very first one we can deal with is negative 54. It's really easy to get rid of. I'm just going to divide both sides by negative 54. 0 divided by anything, 0 is like a black hole. Eats it up, it's gone. So now we're left with this. Okay, but I can't quite get rid of each of these in the same fashion because there's a variable attached to both of them and we don't really know what their values are. So in other words, we're about to embark on a concept of two numbers. So we call it, you ever seen that symbol as a number?
Yeah.
Yeah, okay. So a number times a number is equal to 0. Well, how many different ways can we do that? Turns out there's really only one, or you could say in technicality, two ways to do that. One of these numbers has to be 0. There's no other way to multiply mathematics to 0 unless you're multiplying by a 0. So in other words, what we're saying is either this number is the 0 or this number is the 0. It's got to be one of them. We have two there. It's the only other way to do it. It's possible both are 0, which is fine. That's not going to change our answer in the end, you'll see. So what we do at this point is we take this bracket and we say, okay, well, let's set u equal to 0. 0 is equal to x minus 3. And then we take this bracket and say, okay, what happens if we set this bracket equal to 0? 0 is equal to x minus 1/3. When we go to isolate, same stuff we found before. The 3 comes over, x is 3. Isolate, 1/3 comes over, x is 1/3. So while this algebraically is a really long process, okay, when we go into our factor form, if we've set it up correctly, where our coefficients are both 1s, you can literally just look at these numbers and you just take the opposite one and go, hey, that's what it is, okay? Now, what if, though, the very original question started here? Do I have to do all these steps all the way down here to figure out zeros? Not technically. I'm going to show you what we could have done. I'm going to bring this over, and it said y was equal to 3x minus 9, 6 minus 18, right? Minus 9, and then 6 minus 18x. If they had said find x-intercepts, it's the same process. Set y equal to 0. 0 is equal to these two brackets. These already are just two numbers. When you have a bracket and a bracket, think of them as one term times another term. We could have gone right from here. 0 is equal to 3x minus 9, or 0 is equal to 6 minus 18x. Will things change? This is what we're exploring or trying to find right now. When I bring negative 9 over, it becomes positive 9. And when I divide both sides by 3, x is 3. That's one of the values we got before. Over here, I'm going to bring negative 18x to the other side just to make it positive. So 18x is equal to 6. When I divide both sides by 18, x is equal to 1/3. That checks out also. Exact same things. So this concept of setting an equation equal to 0 to find its roots or x-intercepts is really important. You're going to have to use this over and over and over again further on. But let's go back to our factor form. We got it into our proper factor form, and that was this step here. It's got some highlights on it. This equation here is our specific equation in its factor form. We can use this to quickly find x-intercepts, which we have. We can use this to find a vertex and the optimal value. So we're going to take that equation, or the version of the equation, y equals negative 54. It was x minus 3, I believe, and x minus 1/3. And now that we have our roots, we can plug it into our axis of symmetry. So we say 3 plus 1/3, if you remember this formula, right? That's the 1x value, one root, plus the other root divided by 2 is equal to your axis of symmetry, which is a line that runs through the middle. This is going to give us what I got to get, an improper fraction here. 3 is a third. 3, 9, 10 over 3 divided by 2 is the same as saying 10 over 3 times a half, which gives me 10 over 6. So my x value of my vertex is at 10 over 6, which is, what is that as a number? 1 and 4, 2/3, 1 and 2/3, I guess, or 0.666. Okay, we've got a value there. How do we use that if we're going to graph? Well, we've got some good information, actually. We've discovered that 1/3 is one of our x-intercepts. 3 is one of our x-intercepts. And then 1 and 2/3, which I guess is about visually here. I'll do my best to draw it. Is about there. That looks like it's directly in the middle of those 2 points. The last piece we need to find is the y value of the vertex. Now we already know that this opens downwards because the a value is negative, so we know we have something like this. But the question is, how far up and down is this piece? Well, we're going to use that original equation. Y is equal to negative 54, x minus 3, x minus a third. And we got to plug this value in. It's a mixed fraction, not nice to work with. I'm actually going to work with this improper fraction instead. So we have negative 54. This becomes 10 over 6 minus 3, 10 over 6 minus a third. Now you may say, okay, I'm going to use a calculator at that point. Nothing wrong with this. This is getting a bit complex. I don't have one handy, so I'm going to just use my fraction rules. 10 over 6. If I make this as fraction, it is negative 18 over 6. 10 over 6. You check this work here to make sure we're right. Minus 2 over 6. I'm going to get with negative 54, negative 8 over 6. And this becomes 8 over 6, which is, if you recall, if these absolute values are the same, we know that we're on the right track here. Hello. And then I'm going to do some math to help me out here, but you're probably going to have to help. This is a 6. I can reduce that to a 9. Negative 9 times negative 8 times 8 over 6. That's going to give me 72. Hey, get out of here there. 72 times 8 over 6. This one I can also reduce. 6 goes into 72 2 times, so I think that's 12. So 8 times 12 is going to give me 80, 96. Is that right? 82. I think this should be 96 in the end. Test from here, if you got a good little calculator. I'm pretty sure this should be 96. 96. Awesome, we got it. So, this is huge number mean. Well, that means that's the y value. The y value is at 96. And our x value was 10 over 6. So if you notice, now the scale is not wonderful, but this is extremely high value. This would be a very, very narrow parabola, which makes sense because our a value is so much greater than 1. It's a very, very narrow parabola we have. So if they ask for an optimal value, that's the coordinate. We could find a y-intercept. That's just plugging in the 0. We have room for that. I kind of do. This y-intercept, if we visually look, is going to be probably very far down this way. We'll prove it just because that's another key piece of a parabola. You know, we only need to solve as far as a question usually asks us. But let's use this piece anyways. This was x minus 3, x minus a third. For a y-intercept, we plug in 0. And then we work again with that 54. So negative 54 times negative 3 times negative a third. Luckily for me, these two, when we multiply, create a 1. They create positive 1. So this is negative 54. Is that right? Yeah, that looks right to me. Double check that piece there. 3 times a third is 1. Negative is positive. Negative 54. So in other words, way down here somewhere is where it would cross your y-intercept. Okay. What happened? A heck of a lot of information happened. Should be negative though. Just because of the two. It's a negative times a negative times a negative. Perfect. Okay. A heck of a lot of info we did. We had a more complex factored form. We common factored out to get a true A value so that it looked like the general form of a factor form. We talked about its benefits. Visually, we can see x-intercepts. We can take a look at the true A value. It gives us some information about opening up, opening down, how narrow, if it's stretched. We also proved that we didn't have to do that to find x-intercepts. We could have just set this equation equal to 0 and found them. Okay. Once we found them, we've built our equation. This specific equation of the parabola helps us find the axis of symmetry, which is the x value of the vertex. We plug that back into the equation, finds the y value of the vertex. And once we have the equation, we can set 0 as x to find a y-intercept. So quite a bit of algebra just to find out how to graph this quadratic relationship.